Hello and welcome to the first in a series of videos on Java multithreading and concurrency. In this first set of demos, I'm going to cover the basics of the thread class as well as the runnable interface. I'm going to start with a few simple programs and then add one piece at a time to show how multithreading works. So for this first set of videos, I'm just using Notepad++ and the command line, but feel free to use whatever works for you. First, I'm going to create a very simple class. We'll just call it first, with a single method called go. And I'm just going to have it print out first 10 times. So we're going to start with 1, we're going to count to 10. And then we're just going to print out first. And then we'll have a main class. Just call it thread1. And that has our main method. I'm just going to create an object. And call the go method. All right, and then we're going to compile it and run it. Looks good, and then run it again. Okay, and that prints out first 10 times. This is all very straightforward. Okay, next I want to add another class. It's going to be exactly the same, but I'm going to call this one second. So I'll just cut and paste it. And it's going to print out second 10 times. And then I'll need to create the object and call the same go method. So now you'll see the two objects are created, and it prints first 10 times and then second 10 times. Okay, what we're after here is to get them to execute not in succession but simultaneously. For a method to execute in its own thread apart from the main thread, that class needs to implement the runnable interface. Let me pull it up for you here. That's all there is to it. Runnable has only one abstract method called run, and it takes no parameters and returns void. Run is just a blank canvas like the main method. Only difference is that main has to be static and take a vararg, and run does not have to do either of those things. So let's change this code to reflect the runnable interface. Just going to change it. Implements runnable. I'm going to say same thing with second. Implements runnable. We're going to change the go method to run. And then I'm going to call run down here. Run. And then second.run. And let's try that. And that does exactly the same thing. The only changes I made were syntactical. Runnable is just a marker interface in a lot of ways. It only indicates that this class has a run method that can be executed in a separate thread. What we actually need to do that, however, are two more things. First, we need this Java thread class, which is also in java.lang. Thread also implements runnable, but the run method that it comes with is empty. It just returns void, and that's it. Now, there are two ways of putting something into that run method, though. The most common way is to pass another runnable object to the constructor. So down here, I'm going to call this a thread instead of first. And I'm going to pass this new first object into the thread. And I'm going to do the same thing with the second. We almost never need to access the runnables directly again, so you'll almost always see it done anonymously like this. We're going to talk to the run method via the thread class instead. Okay, I'm going to pause here and note that when I type thread first equals new thread, new first, I do not in fact get a new thread. What I get is an instance of the thread class, which knows how to request threads from the JVM and monitor the thread's execution. It's really more of a thread manager or thread handler, but many years ago Java just went with thread, so that's what it's called. All right. So now, if I try to run this program, let's compile it and run it. I get the exact same result. Version of the thread class returned has a run method that delegates to the run method of whatever runnable object you pass to it. Okay, so calling first.run on the run method is the same as calling run on the first object. Same thing happens with second.run. So we're done, right? Actually, no, there's nothing in this run method, either in the thread class or runnable interface, that says anything about creating a new thread or anything like that. So let's examine this a little closer. I've created both of these thread objects within the main thread. When I call run from within the main thread, main is then waiting for a return. Each thread has its own instruction pointer. Think of it as a baton that gets passed from one method to another. The calling method always waits for that baton to be returned, even if the return value is void, before moving on. So this program acts just like any other at this point. What I need here is what's called a layer of indirection. The thread class has a special start method that doesn't call run directly. Instead, it asks the JVM to allocate a new thread, and then it hands off the run method to the JVM. Once that handoff is complete, start returns void immediately without waiting for the run method to complete. Its only task is to call run, or not to call run, but hand off the run method. So by calling start here, I finally have a main method and two others that are executing independently. Now, it doesn't look like they're very independent yet, but that's because the two run methods are so simple that the first one completes before the JVM has a chance to set the second one up and fire it up. We can fix that though. To slow this process down, we'll introduce the static method of the thread class called sleep. And what sleep does is sleep causes the thread to pause at that moment for a given number of milliseconds. The one thing you got to remember, is we're going to have to put a try block around this because sleep throws an interrupted exception. So before I do anything, I'm going to put try catch around this. And we're going to catch interrupted exception, E. And I know it's not going to throw it yet, so I'm just going to say let's print out first was interrupted. Okay, and then let's put in the actual command up here. I want it to pause after each time. You have to put in thread.sleep because it's a static method. And then we're going to say 500 milliseconds. So after each time it prints out first, it's going to stop for half a second. And then I want to do the same thing with second. Put in try. And then I'm just going to cut and paste this catch. And indent this. And put in thread.sleep. Again, 500 milliseconds ought to do it. And we'll say second was interrupted now. And let's try this one, compile it and run it. Okay, now you see it's moving much slower, and you can even see that it's going out of order. Second up here goes a couple times by itself. This is handled by the thread manager of Windows, so you have no control over this. I want to show you one more thing before we close out. Remember I said there were two ways of getting the thread class's empty run method to do something. The first way was to pass a runnable object to the constructor, which we did, and it would delegate to that run method. The other way is simply to extend the thread class and override that blank run method directly. And to do that, I only need to make a couple of little changes. First, instead of implements runnable, we're going to say extends thread. Thread already implements runnable, so I don't need to declare anything. And we're going to say extends thread. Okay. And then down at the bottom, because this is already a thread now, I don't need the new thread part. I can just say thread first equals new first. And thread second equals new second. And let's run that. And it does exactly the same thing. Okay. You can also add your own constructor if you need to pass the thread a value at creation time, or add any other methods you want to do. Normally, though, you would just implement runnable unless you really and truly need to mess with the constructor for the thread or add your own methods or something like that. Implementing runnable separates the action being performed, the run method, from the task of creating and managing the thread that's going to run it. Also, you can only inherit from one class in Java, so extending thread closes off the possibility of inheriting from other classes. All right. I ended here with thread because in the next videos I want to go over the most common methods of the thread class besides just run and start and sleep. So thanks for watching. I'll see you on the other side.